In this video, I'm going to show you how to add MCP servers, any MCP server, to your LangGraph agents. And this tutorial is going to be specifically for agents that you've built with LangGraph, but a lot of the concepts do apply to some of the other frameworks that you might be using like Crew AI or Pydantic AI. We're going to cover how to build your own local MCP server, how to add pre-built MCP servers that you can find anywhere, and how you can configure some more complex MCP servers that require environment variables and API keys. Like today, we'll be setting up Supabase. So if that sounds good to you, let's get into it. So in the last video on MCP, we did a deep dive into what it is, how it works, and most importantly, why it matters, and why I think everyone in the AI space, whether you're an end user or an AI engineer, developer, or even a company trying to adopt AI, why I think you need to know MCP. If you haven't seen that video, then I highly recommend you go check it out, because if you don't know the why behind MCP, then I think you might be missing a lot. We kind of went through what things would look like at a typical company or for an AI engineer if you didn't have MCP versus having MCP, and you go from this very sad state to this very beautiful, organized, and standardized state. So definitely go check that out. The link will be in the description as well as in a card in the video. We're not going to go into all that detail in this video since I covered it already in the last video, but I will give you a really quick refresher. So with MCP and the new architecture, we have these three new aspects. You've got an MCP host, which is essentially your AI application. This could be an IDE like Cursor, or it could be a desktop app like Claude, or your own code, which is going to be what we're going to do today. We're going to integrate it into our own agent application. So the MCP host would have your code for your LLM and your agents. And before, you had to connect those agents through tools to all of these external resources. Now what we do is instead we create a single client that lives on the host, and the AI agents can interact with this client, but the client is responsible for now making all of those connections to these external resources. Those could be hosted remotely, like a GitHub MCP server or a Slack MCP server where you're actually using the APIs, or they could be hosted locally where the MCP server is just running off of your computer. And typically you're going to use two different modes of transport or modes of communication between your server and your client. If you're hosted locally, typically you'll be using the STDIO or standard in and out protocol. That's going to be a lot faster and you can stream a lot more data. But if you're on a remote server, you're typically going to be using server-side events or SSE, and that's just sending small packets of information, which is typical over HTTP. So that's the MCP host, client, and the servers. We're going to spend time building this client ourselves. We'll also spend some time building our own MCP server for a custom backend. And finally, we'll talk about the difference between using a pre-built MCP, whether it's hosted remotely and you don't have to install anything but just run it, versus one that you might clone from a repo somewhere to your own system and have it run locally, but still be using a pre-built server like the file system. Let's get into a demo of what we're going to be building today. This is going to be similar to the data analyst agent that we created using LangGraph in the LangGraph intro video, but we're going to expand on that and we're going to give our agent access to several MCP servers. Eventually, the analyst will have over 50 tools, and it's going to really unlock the capabilities and the functionality that the analyst has to do work for us. Before, all it could do was load data and query data. Now we're going to give it access to actually manage projects, do version control using Git. It's going to have access to our GitHub, so it can actually push repositories to GitHub. And it will be able to manage projects using the local file system, as well as look at our projects on Supabase. So to get started, I'm just going to ask it what projects we have. This particular MCP server is a pre-built server that we didn't configure, we didn't write a single line of code for, and we can specify the specific folders that we want to give our LLM or agent access to. It's gone ahead and read what's in the contents of the projects folder, and it sees that there's one project named test. I'm going to ask it to create a new project called OnlyVans. So it's gone ahead and created a new project, and that means that it's basically initiated a new Git repository, created a main.py script file in there that we will be adding to later on. And it's also created a data directory, which is not going to have any data right now, but it essentially has executed this workflow to create a new project. And you'll see for this one, there is a prefix data flow because I wanted to distinguish tools that are being called from our MCP server, the one that we are going to develop. And so you can see it is now accessing the tools in that one. So far we've used the local file system, data flow, which is our MCP server, and also Git. Actually, I'm going to switch over to that project folder. So this is the new OnlyVans project that we just created. And I'm going to go in there so you can see all the files that we've created. This was done by initiating a new UV project, but this main file is empty, as you can see, and data should also be empty. I'm now going to copy over some data so that we can start messing around with it. And I'm going to ask it to load this for us. Notice that it first calls this list directory tool. So again, it's using the file system, and it's going to go in there and read what files are in here because I'm telling it that I added a CSV and I want it to load the data, but it doesn't know what the name of that CSV is. So it's going to run that first. It then sees the name of the CSV and it's going to call this load data. So now that it's loaded, we can actually start working with it. And I'll ask it to show me the first few rows of the data. So it should be able to query the data, and that is another tool that comes from Dataflow. And now I'll just give it some simple instructions to start manipulating the data. And to do this, the agent is able to write to this main.py file, which again it's just a dummy file right now that UV created, but it's able to write to this to start taking action on the data. So I will ask it to perform some transformations. So again, here it's using the local file system. First, it wants to check what's already in main.py because it doesn't know the contents yet. It just has the print statement, and then it's able to go ahead and add some code to do all of that manipulation. And then once it does that, it's going to again use several Git tools because I asked it and it's in the system prompt to maintain clean versioning. And so here it's going to add the changes it made to Git, and then it's going to commit it with a nice summary of what it did. So finally, I want to also demonstrate, I set it up with Supabase, and it has my API key, so it has access to my Supabase account, and I can ask it, this is going to be totally unrelated, but I'll say, list my projects on Supabase. So for example, if you want to set up an agent that works with your existing workflows and set up some automations or whatever, here you can see how you can manage all of your Supabase projects with this same agent. So it's able to see that I have 2 projects, it gets me the IDs, and I could ask it, what tables do I have in the OnlyVans project? This is the project that we used in the intro to LangGraph video. It's gone and looked at the schema, and then it's pulled all of the tables in the schema. These are all from deploying our LangGraph server API that we did also in one of the previous videos. So to get started, you're going to want to clone the repo. The link will be in the description below. And you can follow along in the README to that repo as well for the installation instructions. You're going to want to have UV installed. If you don't have it, I'll also include this in the description. It's super simple to set up. You can do it on Windows or Mac. Once you have the repo cloned locally, you can cd into the project, open up a terminal, and I'll just clear mine here. Run UV sync. And because we have this PyProject toml in here, which has all of the dependencies defined, that will go ahead and install everything that you need. If it's your first time running it, which it should be, then it'll create this virtual environment for you as well. But if you don't see that, you can always run UVVENV to create a new virtual environment. I'm not going to do that because I already have it. And then you can run UV sync. Once you do that, you're also going to want to run uv pip install -e space dot and make sure you include that dot. That's going to install the current project as an editable package, which means any changes you make in the project will be reflected in the library. Finally, the last setup piece is going to be adding your OpenAI API key. The rest of this is optional, but if you do want to add tracing to your project, which I always like to do since it's free anyway, up to a certain usage on Langsmith. So I do recommend adding an API key for that. And then these last two ones we'll go over in a bit, but this is going to be for setting up the MCP servers. All right, let's get into some code. We're going to start by showing you how to build an MCP server from scratch. And we're going to do that for our local MCP server that we're calling Dataflow. That's for just executing some local data operations. And then I'm going to show you how you can set up a server copying pre-built code that is on GitHub or anywhere else. And then we're going to configure all of those MCP servers in our mcpconfig.json. And that's where we'll add these other ones like the one for GitHub and Supabase. And once we have all of the servers configured, I'll then show you how to build the client. That will give our agent access to all of the tools. This is only going to take a few lines of code, so I think you'll be really surprised at how easy this is to set up. Okay, so the way this project is organized is you have all of your project files out here and you have a directory called Scout. This is where all the code that we care about lives. In here, you're going to have your typical graph.py that you have with any LangGraph project. That's where we build our agent. You're also going to have the client.py, which is where we're going to be setting up our MCP client to talk to all of the servers. And then you have the myMCP folder in here, which is a Python module. So it's got the init. And within this folder, you have another folder called local servers. This is where you would put any of the servers that you're going to be developing yourself locally. And this dataflow.py is our MCP server that we wrote. This is our custom backend. There's another one in here. This is just something I copy pasted from the examples online. I just want to show you that you can literally take code from online, whether it's a repository or some example docs, and just paste it in here and it'll work. You won't have to change anything about your client or the way that you're setting up the other servers. Because MCP is standardized, everything is always defined in the exact same way, and that's really the beauty of MCP. So now let's get into Dataflow and build our first MCP server. You're always going to start by importing this fastMCP class. This class can be instantiated by passing in a name. There are some additional params which you can look through the docs. One thing I'm really curious about, which I haven't done myself yet, but apparently you can add auth to this. So that would be really cool to protect your MCPs if you were hosting them online remotely. But essentially you're going to instantiate this class by passing in a name, and then you can assign it to whatever variable you want. Here we're calling it MCP. That's what they do in a lot of the document examples, but you could easily call this server or app. And then we're going to have a chunk of code for a custom class that I implemented for my custom backend. And this is just kind of mimicking a data orchestration backend that I might build out and host somewhere. Typically, you would access this via an API, but because this is a simple example, we're just going to do everything inside of this custom class that I defined. So now that we have this custom class, this is essentially our backend services. We can create some tools around that. So we're going to have one tool for each one of those methods. And the way that you define a tool is you'll create a Python function. And then the way you're going to register it is just by using this tool decorator. So you're going to do @MCP or whatever you named your server. And this is exactly how you would do it for a fast API. So once you point to the server, you're going to call the .tool decorator. Now the way this tool decorator works is it's going to take your function and create a tool definition around it. By default, the name of the function becomes the name of the tool, and the doc string is used as the description of the tool. So it's really important to have a very clear doc string of what this function does, what are the arguments that go into it, so that the LLM knows how to call this. Then once you've defined all of your tools, at the very bottom, you're going to have your if name equals main and call mcp.run on that server. And this is the same as if you would run a UVcorn server, for example, except here all we're going to do is specify the transport method. And again, this transport method is just the standard in out. You have the option to do stdio or SSE, and SSE is the server-side events method. Both would actually work for a local server. It's just that stdio is faster and will allow you to send more data. So it just makes more sense if you are running a local server to use this method, but you can easily use SSE. On the flip side, SSE is the only method that you could use if you were doing this remotely over the internet. And that's literally all it takes to create an MCP server. This is less than 100 lines of code, and most of it is this whole custom class that I wrote. So having this decorator makes it really convenient because all you have to worry about is defining the Python function. Okay, so we just created our very first own MCP server that is going to run locally. Now we need to tell our client how to connect to that server. And the way that you do that is through the mcpconfig.json. I'll have all of these resources linked in the description below, but if you go to the official MCP docs, you'll see they have a list of official servers that are supported and then a ton of third-party servers. And if I just click into any one of these, let's say like Google Drive, you'll see they all include, after the instructions, the exact same JSON spec that defines how you connect to that server. So this is the really nice part about configuring MCP servers is all of the definitions here are standardized. So you're always going to define it in exactly the same way, where you have at the top level this MCP server's key, the name of the MCP server, the command to run it, and then the arguments that you would pass into it. This one doesn't show it, but in some cases you need an environment variable like this, and that's going to be if you're using, for example, an API or you require some authentication credentials. But essentially all MCP servers are defined in the same way. So if we come back to our mcpconfig.json, you can see here that it doesn't matter whether it's a remote MCP server that you're connecting to through the internet, or it's just one that you developed here locally. This is how we're setting up data flow. We're calling Python to run this specific script. So the command tells our client how to run and where to run this server from. And the mode of communication that we're using is that stdio transport. Now we can take a look at all of these other MCP servers that we configured. We have the file system MCP, which the source code for this is on the repo. So you can see the difference between these two. This is a local file that we're running from our Python file here. And then whenever you see this @model context protocol, these are servers that are being pulled from GitHub. So all of the server code is on GitHub, and we're going to be running it using npx. And for this file system MCP, you can pass an additional argument where you specify which directories on your local system this server can access. So again, adding security to what the LLMs can do on your local system. And the way that you can set it up with environment variables, because again, you never want to add secrets here, since this MCP config JSON will typically be pushed to GitHub. You want to define secrets in this way, where you have a $, bracket, and then the key, and then end bracket, and then you'll be able to load those in, which I'll show you in a bit, from the .env file. Here's another example that we're actually pulling locally. So we're using the uvx command, which is a UV command. That's going to go into our virtual environment where we have already installed the MCP server Git. And if we open up the Pi project toml, you'll be able to see that it is here. It is a dependency. So for some of the MCP servers, I mentioned you would either have to clone or pip install and pull the actual code for that server onto your local system. So that's how we're running Git. So the last couple of MCP servers that we have here are the GitHub and Supabase servers. I added these two to, one, showcase the functionality, but also just really show you the broad range of different ways you can run MCP servers. So this one is running using the Docker command. So you would have to have Docker installed to run this MCP server. So each MCP server can have different requirements for how you would run them. And here we are also going to have to pass in the GitHub personal access token. So this is an environment variable, and it has that same syntax that I showed you above. And the same thing with the Supabase MCP. So if you do want to use these two, then you are going to have to walk through the README examples on the GitHub repos for these two MCP servers. They describe how to get these access tokens, and you're going to want to put them in your own .env file. I'm not going to open mine to expose my secrets, but again, here is where you would put those in if you do want to use those two MCPs. I just made some corrections there, but this is the file system directory that you would define if you wanted to constrain what folders your MCP server has access to. So I previously also mentioned that there's a ton of directories online where you can find MCP servers. Glama is one that has a bunch of open source MCP servers. So you can go through this and find an MCP server pretty much for anything. And for every MCP server, you'll be able to go through the docs, and they will always have that JSON connection that you need, which you now know how you can just copy and paste that into your MCP config. In order to make sure that we have the environment variables safely loaded into the MCP config at runtime, rather than having those hard-coded into the MCP config, we have this additional file config.py. It's going to use the load.env method to load in our environment variables from the .env file in the root. And then we have a method that will simply iterate through all of the keys in that JSON, find the env key and the args key. And then for each item within those two, it'll search for a simple string match where we're looking for that $ bracket, grabbing the environment variable that's sandwiched between the brackets, and then replacing it with the actual environment variable that we loaded. So it's pretty simple. We're just going to do a check just to make sure that mcpconfig.json is actually there. If not, we raise an error. We then load the file and then pass it to that resolve environment variables method. And then we're going to have this MCP config that we can load from this file directly. So we're not actually loading the MCP config.json itself. We are going to load it from this config.py. Okay, so that's the MCP config. That's how you can add multiple servers in a single config. Before we get into creating our MCP client, we're going to go through what the agent looks like. So it's a typical LangGraph agent. You start out by defining your state, and here we have probably the simplest state you can have. We're just tracking the messages of the conversation. And typically in LangGraph, you'll have a method to build the graph. In here, I have a really long system prompt, which I'll get into in a bit. But you always start out by defining your assistant node, and then I have a super simple graph here. We can actually run this to visualize it. But this is essentially one node for the assistant, and I've named him Scout. And then you have your tool node for calling tools. But you'll notice normally we don't pass in a list of tools like this when we're building the graph, and that's because we would typically already have our tools defined. We would potentially have them defined up here or be importing them from a tools file. In this case, I'm leaving it as an argument here that can be passed in because we're going to actually do this at runtime in our client. So when our client pulls the latest tools each time we run it, it'll pass that set of tools, which can change as we're interacting with the agent, but we'll pass that set of tools that's available at that moment to the agent. So that's why we're taking it in as an argument here. And once we define our LLM, we're going to check if we did in fact pass in any tools, if that list is not blank, and then we're going to bind the tools. The other thing I'm going to do is get a JSON string for every tool in there, but I'm only going to look at the name and description for each tool and then inject that into the system prompt along with the working directory that we defined in the MCP file system. And that's just to let our analysts know that we can scroll up here to see we're specifying that we have within the file system this directory that the agent can access, and only within that directory can it perform its work. And you've got a lot of descriptions in here about the context for the agent, the tools that it has access to, how we want it to version control, and how to interact with the data, etc. And then we have this section where we're going to inject the tools. And again, because that's happening at runtime, we're just going to leave this placeholder and we're going to inject it into the system prompt here. And so now we can take that LLM and use it how we normally would in our graph. Now let's look at how we build the client. So LangChain actually came out with this library, LangChain MCP adapters. This just makes it even more convenient to define a multi-server client, which can connect to all of our servers through just one client. So this is what we're going to be using. You're going to want to import this multi-server MCP client class. If you've worked with LangGraph before, then everything else should be very straightforward to you. Here we're importing the MCP config, and down here we're importing that build agent graph and also the state. Up here I've defined the typical stream graph response method, and I'm going to be passing in three things to this. One is the input for the graph itself, and then the config if we want to be using the checkpointer and memory function of this agent. So hopefully you've seen this before, but essentially we're just going to iterate through every chunk in this graph stream after passing in the input and config and specifying stream mode to messages. And then we're going to parse each chunk and pull out any tool calls that we see so that we can print the name and arguments of the tool call. So then you have your main function, and if you kind of ignore this section here, this is basically the only thing that's new, the only thing that's different. Everything else should look familiar. We start out by specifying our graph, passing in the graph config, and then we're going to get to our agent loop. So the way you use the client is just by instantiating this multi-server MCP client that we imported from the adapters library. We could define what you saw in the MCP config JSON file just as a dictionary here, but in this case we're just importing it and then passing it in as an argument to connections. So that keeps things really clean, and you can manage all of your server definitions here in one place. So it's really straightforward to use this client. You just want to call it like you would with any context manager. In this case, we're doing it async, so we're calling it with multi-server MCP client as client, and then now we can access that client in this context. And to get the list of tools, we just call this method to get tools, and we assign that to the tools variable, and then we can pass it into the build agent graph. And again, that's going to inject all of the currently available tools into the system prompt to let our agent know, hey, these are the tools you have available to you. And it's also going to bind them to the LLM so that it can then call those tools. This client is going to take care of then calling the actual tools, because remember, the agent, if we go over to our graph now, before we would have had the tool definitions here in the same place as executing the agent. But now what's happening is when we identify a tool we want to call, that goes back through the client and then to the server. The server calls the tool and returns the response to the client, and then that response is given back to our agent. So that's how you create a client and use it with your LangGraph agents in just a few lines of code. And this is all made possible by this class that comes from the LangChain MCP adapters library, which is just going to make things a lot more convenient if you are working with LangGraph. If you're not working with LangGraph, then I'll just quickly add some general context about building clients, and hopefully this will be useful to you if you're using a different framework or building agents from scratch directly with the APIs. Generally, when you build an MCP server, it's always going to look similar because we're going to be using the MCP library and the fast MCP server. And you'll define your normal Python functions as tools and then register them using the tool decorator. For clients, on the other hand, it's a little different. If you wanted to build a client from scratch to work directly with the LLM provider APIs like OpenAI or Anthropic, then you can follow this quick start example that is on the official docs. And it shows you how to initiate a connection with the server and then pull the tools for your agent. If you're working with another framework, though, each framework is going to have its way of defining tools. So each framework is opinionated about how it defines tools. Pydantic, for example, will have its own model for tools, and LangChains will look slightly different. So every library will implement tools in a different way. And because of that, clients will be specific to those frameworks. Luckily, all of the major frameworks have now adopted MCP in their own way, and the way that they implement their clients is going to be very different. So you'll have to look at that specific framework's implementation. For example, Pydantic AI has a way of binding MCP servers to the agent class. And so instead of creating a client and then interacting with it in the context of running your agent loop, with Pydantic AI, you would just feed in multiple servers into this MCP servers argument, and the agent will be able to interact with those servers directly. And then similarly with the agents SDK or the agents library from OpenAI, you also have a similar way of adding MCP servers directly to your agent. So it's a bit different than LangGraph. So you'll want to check for your particular framework how the clients are implemented. But in all these cases with frameworks, they have already implemented their solution to adding MCP servers very easily. And so it should be pretty quick to get started. That is going to do it for today's video. I hope you learned a lot and got a lot of value out of this video. And if you did, please drop a like, as it does help out my channel a lot. And consider subscribing for a lot more content on how to build AI for the real world. I would also love to hear if you guys have any ideas for videos that you'd like to see next. Just let me know in the comments below. And thanks so much for watching, and I'll see you in the next one.